Hello, students. So this video is going to be a review, a review of tiles, and specifically what each tile is worth in value, and how we can write an expression with tiles. Okay. So our main goal for this video is we're trying to write the expression 3y minus 4x plus 2 with tiles. That's our main goal. So before we do that, we need to review what each tile is worth. So right here, we have our unit tiles. We have a positive unit, okay, and a negative unit. They each have a value of 1, okay? And if we want to build an integer greater than 1, we need to use multiple tiles. So for example, let's say I want to build the integer 5, okay? That means I need 1, 2, 3, 4, 5 unit tiles, okay? So that's how I would build 5. Now let's say that you had minus 3, okay? So 3 is an integer, but it's minus. And remember, this is something that we did learn in 7th grade. We can rewrite subtraction as adding the opposite. So when you see a minus 3, you can also think of that as adding negative 3. So whenever you have minus a number, you're going to use negative tiles, specifically the negative ones tiles, if it's an integer, or as we learned yesterday, a constant. So this right here is how we would represent the constant minus 3 or negative 3 with 3 negative 1 tiles. Okay, now we have our x tiles, and they work the exact same way. Now, one thing I want to clarify, actually, before I clarify, I'll show you we've got our y and our minus y tiles, our x squared and our minus x squared tiles, and our y squared and our minus y squared tiles. So we have our pairs of tiles. We have our positives here, and we have our negatives here. Whenever there is a plus of a variable, we're going to use the positive tile. Whenever there is a minus or a negative of the variable, we're going to use the red negative tile, okay? Now let's say that we need to express 2y. What I'm going to do is I'm actually going to place 2y tiles, because 2y doesn't mean I have 2 and I have a y. It means I literally have 2 y's, which might be hard to think about. So let's think about it a different way. When I say, okay, that I have 2 apples, that doesn't mean I have 2 and an apple. That means I literally have 2 apples in front of me right here. 1, 2. I can hold my 2 apples. Okay, I have them, I see them. It's the same thing here with these variables. When I have 2 y's, that doesn't mean I've got 2 plus y. That means literally I have 2 y's. Now, the difference is you can't really hold or eat a y, but with this tile, you can see this is what the y represents. It represents an unknown value, okay? And this tile is used to represent that unknown value of y. So we have 2 unknown values, and these tiles physically represent that we have 2 of this unknown value, 2 of this y variable. So in terms of actually writing this expression, I really could have kept those on the table on the expression mat, because the first term is 3y. So I'm actually going to drag 1, 2, 3 y's here. You don't have to group them together, but it does make life easier. Then I'm going to get 1. Oh, my mistake. I saw 4x and I went for positive, but really It's minus 4x. So I don't want the positive, I want the negative. Because remember, I could rewrite that using adding the opposite. You may have learned SAO, same add opposite. I can rewrite that as plus -4. So really this is -4x's. So I'm going to get 4 negative x tiles. Okay. And now lastly, I've got this plus 2. So I'm going to get 2 unit tiles. Now, as a reminder, it doesn't matter where you place them on the mat, but I'm placing them in groups like this because it's a bit easier for us to see that this is literally 3 y's, this is literally 4 negative x's, and this is literally 2 unit tiles, which is exactly how we would represent this expression with tiles. Okay? So I hope this video has been helpful. Please feel free to reach out if you have any other questions, and I will see you later.